Alright, this video is going to be a brief video on just reviewing how to use a quadratic formula to solve a quadratic equation. So, if you remember the quadratic formula, every good math student should know this by heart. And basically what we do is we take a quadratic formula in standard form and plug in the coefficients. So let's look at this example here. In this example, A would be 1, B is -8, and C is 12. And again, I'm getting those numbers from the standard form of a quadratic equation, where the coefficient of x squared is A, coefficient of x is b, and the constant term is c. Then we just plug these in. So this is going to be a -8 plus or minus -8 squared minus 4 times a times c, all over 2 times a. You want to take your time in putting this into the equation. Don't take any shortcuts. Just stick it in with parentheses around the values. That way, if you try to do too much in your head on the first step, you'll probably make a mistake. So now we can simplify. So that's +8. -8 squared is 64. And then -4 times 1 times 12 is a -48 all over 2. What's 64 minus 48? What's 14 minus 8 is 6. 6 minus 5 is 1. 16. And this particular equation is coming out so beautiful, there's not even any radicals. So when you get down to this step here, this 8 plus or minus 4 over 2, we can simplify that to two answers. 8 plus 4 is 12 divided by 2. 8 minus 4 is 4 and then divide by 2. So our answers come out to 6 and 2. You know when your answers come out perfect like this using the quadratic formula? Perfect like whole numbers like this, that means you could have solved it by factoring. And at this point you go, no, that would have been so much easier. Oh well. Okay, let's look at another example. In this example, A is 1, B is 1, and C is 6. So we plug it into the formula. -b plus or minus square root of b squared minus 4 times a times c, all over 2 times a. So we have -1 plus or minus the square root of 1 minus 24, all over 2. And when we end up with a negative number under the radical sign, that means our solutions are not real. Okay? There'll be two complex solutions. So this is what we do with this. If you recall, let's change colors here. Little I is called the imaginary unit, and it equals the square root of -1. So we're going to write this with an I, and those are our solutions. Now what this means is that this particular parabola is not crossing the x-axis, so it's a floater. So that's why the solutions are not real. If quadratic function crosses the x-axis, you get two real solutions. when you don't get real solutions, you still have a parabola. If you graph it, it's still there, but it's just not crossing the x-axis. I want to take a minute to talk about simplifying these answers. So I'm just going to not do an equation, but I want to show you what to do if you're simplifying. So let's say you have 8 plus or minus the square root of 5 all over 8. The temptation here is to cancel those 8s out, but you can't do that. Okay? The only way you can cancel something out is if all 3 pieces of this have a common factor, and only 2 out of the 3 have a common factor here. Now, if you had this equation, or answer rather, so let's say you had x equals 3 plus or minus 3 root 2 all over 3. In this case, you could cancel the 3's out because it would be like doing this. And then you can see the 3 is a common factor. So you'd have 1 plus or minus root 2. Okay, let's look at another example. Let's say you have, you wind up with x equals 10 plus or minus 5 root 3 all over 5. Then you could have a common factor of 5 on the top with the bottom, and you could cancel those 5's out. So you'd have 2 plus or minus root 3. All right, have a great day.